The idea in simplifying square roots is to be able to factor what is underneath the radical to find pairs to move out. Reviewing that square root is just basically saying that if we can find two numbers, the identical numbers that will multiply to this, then this is how it reduces down. So we see here that in fact 16, the square root of 16 is 4 because 4 times 4, two of them, equals 16. So if we come back here to start working on the homework, then we're going to see that we're first dealing with the square root of 50. So let's go ahead and take 50 and we'll go ahead and just factor that. Alright, let's just go ahead and put our square root here so we know what to leave underneath and what to move to the outside. So 50, of course, is the same thing as saying, let's just say 25 times 2. Okay, and then 25 multiplies to 5 times 5. And so we see here that we have a pair of 5s. Now again, remember that when we factor this number, this radicand right here, we are factoring it down to the prime numbers. The prime numbers, remember, is going to be that you cannot multiply any two numbers other than one in itself to get to that number. So, of course, 5 has no other multiples than 1 and 5. So does 2. 2 has no other multiples besides 1 and 2. So we see here that if we were to actually take this 50 and multiply its primes, then we would see 5 times 5 equals 25 times 2 equals 50. This is what we call the product of the primes. So since we have a pair of 5s, we'll move one of them to the outside, and anything that we have left we leave underneath the radical. So when this reduces, it will reduce to 5 square root 2. Alright, so let's look at 18. Okay, 18 is going to factor down to, let's say, 6 and 3. Well, 3 is a prime number. 6 is not, because we know that 3 times 2 equals 6. So now, again, putting our radical back up here, the square root sign, we see that we have a pair of 3's. Okay, so we'll move one of them to the outside and leave the 2 that's left over underneath. Okay, so the square root of 144. Well, if you're not aware that 144 does have a perfect square of 12, we can go ahead and we can simplify this. Okay, so we know that it's even, so we can go ahead and just say 72 times 2. Alright, that's going to be 144. Alright, then again we can say, okay, well, let's say we did know that 8 times 9 equaled 72. Okay, so then we have the 3 and the 3. 8 factors down to a 4 and a 2, and then the 4 comes down to a 2 and a 2. So again, now we have 3 pairs of numbers. We have a pair of 2's, we have another pair of 2's, and then we have a pair of 3's. So we'll move one of each. Assuming that we didn't know that it was a perfect square, we would go ahead and leave the radical still up there. And because we have one pair of 2's, we'll move one of them out here. Since we have one pair of 3's, we'll move the other one out here. And since we have the other pair of 2's, we'd move it out here. And of course we see that we don't have anything left to put underneath there. So we can kind of eliminate that and see that 2 times 3 times 2 is 12. What that's telling us is that if I was to multiply 12 by itself, it would equal 144. So the square root of 144 has a perfect square, which is 12. Because again, we know that 12 times 12, or let's just use exponents here, 12 squared equals 144. Okay, so let's look at the square root of 32. We'll go ahead and factor 32. Let's go ahead and put our radical over here. Alright, so 8 times 4 is a multiple of it, and then 2 times 2. Again, 8, we have 4 times 2, and 4, we have 2 times 2. So now we see that we have a pair of 2's, so we'll move one of them out here. And then we have another pair of 2's, and we'll move that out here as well. And then we're only left with 1, 2 left. So, simplified, 2 times 2 is 4, and we're left with square root of 2. Okay. 12. Again, we're going to put the radical sign right here, and we're going to go ahead and factor 12. 12 we could say is 4 times 3, and 4 is 2 times 2. So again, we see that we have the pair of 2's out here, and we are left with 1, 3 left over. So we'll leave that there. Okay. 75, put the square root there. Factor 75, well, 75 is the same thing as saying 25 times 3. It's a product of those two numbers. And then 5 times 5. So we see again, we have a pair of 5's. We'll move it out here, and we're left with the 1, 3 that we will leave underneath. Okay, so now after we kind of move away from simplifying radicals, we can go ahead and combine them. Once we've simplified them, we can go ahead and combine them if and only if they have the same radicand. Okay, this number right here, this 5. So we see here that now we can go ahead and just add the two numbers out in front of the radical. So we have a -2 and a +2. So again, we can go ahead and move those to the outside, and we're adding them separately. -2 plus 2 square root 5. It's almost like we're factoring out a square root 5, right? We factored it out, and we're left here. -2 plus 2 is 0. Well, 0 square root 5 is the same thing as 0, because anything times 0 is 0. Alright, so let's go ahead and factor out the square root 3, seeing that we see that they're like terms because we have the square root of 3 applied to both. And then we're going to have left the 3 plus 2, which is going to be 5. So we have 5 square root 3. Okay. Again, factoring out the square root 2. I'm kind of doing this a little bit different each problem, it seems like. The coefficient here is going to be a -1. So we have a -1 plus 3. -1 plus 3 is 2 square root 2. Factor out the square root 3, since both of them have square root 3, and we're left with a -2 minus 2. -2 minus 2 is -4 square root 3. So here we have 3 terms. Okay, we have 3 terms, and we see that we have a square root of 6, a square root of 6, and a square root of 2. Nothing we can do with this. There's no other like terms with it. So we have the square root of 6. We can factor that out, and the same thing we did before in the other problems, -3 minus 3. And then we're still left with this 3 square root 2. -3 minus 3 is -6 square root 6 plus what we had here, 3 square root 2. Now again, we can't simplify this right here. The only multiples of 6 is either going to be 6 and 1 or 3 and 2, and neither one of those have anywhere else to go. That's the product of the primes there. So here we have 3 square root 5 minus square root 5. Nothing here with the square root of 6, so we're going to bring that down. Alright, and then here we'll go ahead and factor out the square root 5, and we're left with 3 minus, remember, coefficient there is 1. Alright, we have negative 2 square root 6, and 3 minus 1 is 2 square root 5. Okay. Here we see that we're going to have to go ahead and simplify this square root 12 first. So the square root of 12, let's just kind of come over here to the side. We have square root of 12, 4 and 3. And then we have 2 and 2. So when we simplify this square root 12, because we have a pair of 2's out here, we're going to move that to the outside. Okay, and we'll bring the 3 back underneath the radical. But remember, we still have this 3 out here that we're multiplying the square root 12 by. So we have a 3 times 2. And that will simplify to 6 square root 3. And then we can go ahead and simplify and solve the rest of our problem. So now we're going to go ahead and factor out the square root 3. And we have the 6 minus 2, which is going to equal 4 square root 3. Okay, this one's going to be a little bit easier, 14 is, because we already did the work over here for 3 square root 12. We said that when we saw that 3 square root 12 was going to simplify to this 6 square root 3. So let's just use the work we've already done. And we know that 3 square root 12 is going to simplify to 6 square root 3. And then we have the negative 2 square root 3. Okay, so again, we're going to go ahead and factor out the square root 3, and we're left with negative 2 plus 6, which is going to equal 4 square root 3. Didn't realize this initially, but you know what? These two are the same problems. You see how you have the negative out here in front of the 2 square root 3 and the negative out in front of 2 square root 3? There's no difference in these problems. These are the same. Okay, so here we're going to go ahead and simplify this square root 27. Okay, so simplifying the square root 27, let's go ahead and factor this. 9 and 3, 3 and 3, so we see again we have the pair of 3's. Okay, so bringing our radical down, we have the pair of 3's. Don't forget our 2 that still lives up here. And then what's left is this 3 right here that will stay underneath the radical. So this is going to simplify to 2 times 3 is 6 square root 3. And then we still have to bring down this negative square root 3. Okay, so again we'll factor out the square root 3, and we're left with negative 1 plus 6, which will equal 5 square root 3. Okay, and this is the last one. We have this square root of 54. So again, let's just simplify the square root of 54. We're going to factor this. We have 9 and 6, 3 and 3, 3 and 2. Okay, so again we have a pair of 3's right here, so we'll move one of them out, bring down this other 3. Okay, and then here you'll notice that we actually have two numbers that don't have a pair to them. we have a 3 and a 2, so we'll bring those underneath the radical still. Let's just give ourselves enough room. And so 3 times 3 is 9. 3 times 2 is 6. And then, of course, we have the 2 square root 6 here. We're going to factor out the square root 6, and we're left with a 9 plus 2, which is going to equal 11 square root 6. That's your homework.